Hi everyone, thanks so much for coming. I imagine we'll have a few people kind of dribbling in as we go along, but it's really nice to see you here. For those of you who haven't been here before, each month we run a session in this Scholars Library series, and it allows an alum to come and talk about their literary works to those in the community and those beyond. So it's nice to see scholars and non-scholars partner institutions here as well. So thanks for coming. And today we're super excited to welcome Sarah Stewart Johnson to talk about her book, The Sirens of Mars. And thanks to Bob as well for helping organise this one. And we've got Sam O'Sullivan here to moderate the conversation. She's currently reading for a DPhil in condensed matter physics and has graduated from Harvard with an AB in physics and African American studies. She's previously conducted astrophysics research at George Washington University and has also worked at the Smithsonian National Air and Space Museum. So I will post the link to purchase Sarah's book in the chat if you don't have it already, but for now I will hand over to Sam, who's going to give you a further introduction to Sarah and the session, and we can get into it. So if you've got any questions as we go, please feel free to post them in the chat or raise your hand at the end and we can ask them in the Q&A then. So over to you, Sam.
Thanks, Georgie. So excited to be here. Thanks for the introduction. I'm really excited to introduce Sarah Stewart Johnson, Kentuckian model in 2001. Sarah is the Provost Distinguished Associate Professor of Planetary Science at Georgetown University, and her research is driven by the underlying goal of understanding the presence and preservation of traces of life within planetary environments. Her lab is also involved in the implementation of planetary exploration, analyzing data from current spacecrafts, and devising new techniques for future missions. A former White House Fellow and a Rhodes Scholar, she received her BA from Washington University in St. Louis, and then a second BA and MSc from Oxford University, and a PhD from MIT. Sarah has participated in science teams for NASA's Spirit, Opportunity, and Curiosity rovers, which she writes about in her book. And since 2016, she's been a visiting scientist with the Planetary Environments Lab at NASA's Goddard Space Flight Center. Her first book, The Sirens of Mars, Searching for Life on Another World, was selected as the New York Times 100 Notable Books of 2020. And in 2021, she received the Whiting Award, the largest US literary award for emerging writers. So a very impressive bio. Sarah, really excited to talk about your book. I loved reading it. I hope everyone here has got a chance to read it as well. And the first question I want to pose is, the book follows the history of the search for life on Mars, and a fascinating theme you explore throughout your book is this contrast between public imagination and then actual scientific results. So for example, in the anticipation of the Mariner 4 images, the public was really optimistic and hoped to find life on Mars. President Johnson himself hoped to use the mission to inspire a country that was, quote, still reeling from John F. Kennedy's assassination. But after these images were released, President Johnson somberly announced that life on Earth may be more unique than we may have thought. And there was kind of this sentiment of disappointment. So it seems that this search for life on Mars has never been truly neutral, just like we as humans have always really wanted to find life on another planet. So the first question I want to pose to you is, as a researcher in the field, how have you seen public opinion and attitudes towards exploration of life on Mars kind of shift over the past 50 or so years?
Oh, Sam, that's a great question. And it's such an interesting thing too, you know, that moment that you describe in 1965, the images of Mars were just covered with craters. And instead of a planet that looked a lot like Earth, it was a planet that looked like the lifeless, pockmarked moon. And I think it was just staggeringly disappointing to a lot of people working on the mission. And I guess when I sort of look at the evolution of Mars science, it's almost like this hockey stick where we started off with these kind of sky-high hopes and dreams for what Mars might hold, maybe even of civilization back at the turn of the last century, the century before last, to, you know, this really disappointing moment. But it's just been kind of climbing, and especially in my lifetime, there's a period in the 1980s and most of the 1990s where there were no Mars missions, and that was my childhood. But then once I became a university student and sort of during my time at Oxford and beyond, like there's just been this swelling of excitement and engagement. And, you know, we went from this kind of mantra NASA had of following the water to looking for signs of habitability. And now, finally, we're really embracing the challenge of life detection. And so we're returning samples to Earth to look for traces of ancient life. And it's been great. It's been like totally great to see it. And I feel like at this point, there are more resources, more funding, more excitement and engagement headed in the direction of Mars than ever before. We're seeing participation by like a much larger range of players. It's not just the US and Russia, lots of other countries are jumping into the game, even some private companies. And it's just a really exciting time to be a Mars scientist. I guess the one other thing I should mention is we've got new rockets, new propulsion technologies, new ways that we can really address things that are even places, destinations that are far beyond Mars, like even out at the far reaches of the solar system. Now we're not just looking for life on Mars, we're looking for life on moons of Jupiter and Saturn, these wonderful, exciting places like Europa, which has, you know, an ice shell and more liquid water in the form of a giant under ice ocean than all of the oceans on Earth combined. And little Enceladus, kind of a similar setup near Saturn. And then, of course, the biggest moon of Saturn, Titan, which is covered with lakes of ethane and methane, this kind of gasoline world where water is not even the solvent there. And exoplanets, you know, even beyond our solar system, like looking out for stars around other suns. And, you know, like I've seen that in my time as a researcher. You know, we didn't know there were really exoplanets. There were very, very few of them detected, but then sort of in the early 2000s when I was at Oxford and then on through time, you know, now we have thousands of them confirmed, which is really exciting. But I guess just to wrap up, like, you know, I'm still investing a lot of my time and energy on Mars because I think it's a place we can do some really exciting science. It's close by. We've done so much legwork, kind of understanding the context there. And I think that at least like in the short term, that's like the best place to be focusing a lot of my efforts, at least.
Yeah, thanks for that. And I see a few questions in the chat, and I'll try to get those towards the end. I guess I speaking of your research, I'm curious if you can talk a little bit more about the types of research you're interested in, the projects you're focused on. I was really excited in your book when you're talking about how the geologist David McKay observed what he thought to be a nanobacteria fossil from Mars using an electron microscopy technique, since that's the same technique I use in my physics lab, which is very different in nature, but uses similar techniques. So I was sort of struck by the interdisciplinary nature of a lot of the work you talk about. So I'm curious if you can describe what it's like to research such an interdisciplinary field and sort of some of the projects you're working on. Do you constantly find yourself learning new techniques and types of science?
That's a great question too. So yes, for sure. Sometimes I tell my students that being a planetary scientist today, I mean, it's almost like being an earth scientist a century ago, where there's still so much that's unknown. And you really do have to bring together all these different fields, all these, you know, different ways of thinking and approaching problems, especially in life detection, you know, understanding geology and biology and chemistry and physics and like, you know, understanding math and stats and computer science to like really think about how you make sense of data. I just think it's incredibly exciting. And so one of the things you asked was, you know, kind of what some of the projects are. We've kind of two wings of my lab. I have this laboratory at Georgetown, and we've got a molecular biology side and organic geochemistry side. And we do lots of different projects, but I think one of the ones that I guess I'm most excited about these days is this big grant we got from NASA. We've got this huge like interdisciplinary team, which brings together some folks that have never even thought about planets before, you know, some of like the best organic chemists in the world, and you know, computer scientists and like other people that are really tackling this really tough question. And so the whole premise of this project is what, like, we kind of have an idea of like life as we know it, what that looks like, the sort of DNA-based, carbon-based life that all of our life here on Earth is. But what about life as we don't know it? What if life had like a completely different underlying biochemistry or a different kind of molecular framework? What would that sort of life, which we've been calling like agnostic biosignatures, so signs of life that don't necessarily presuppose the same kind of life that we have here on Earth, what might that look like? And it's just been tremendously exciting because it's super interdisciplinary, and we're bringing together all these folks to say, well, what if there's just some level of, say, like underlying complexity that would be associated with life? Like if you found a molecule like ATP, that's like a really complex molecule, and it's very, very unlikely that that formed just randomly, especially if you had that in any real quantity. I've got this colleague who likes to say, if you found a 747 on the surface of Mars, you might have no idea how it got there, but it probably wasn't just random. So kind of doing the molecular equivalent of that, but you don't have to be, necessarily carbon-based or like the same kind of biochemistry to have kind of complexity in terms of the way you build molecules. So thinking about that, thinking about, elemental and isotopic fractionation, compartmentalization, chemical disequilibrium, maybe even just energy transfer for life, like extant life, thinking maybe life, there's this famous physiologist who once said life might be nothing but an electron looking for a place to rest. And maybe we can see signals, that's kind of the most fundamental thing that life is doing, harvesting energy. Maybe we can detect electrochemically life and signatures of life. But anyway, I could talk all day about that. It's been so fun. And it's almost like kind of imagining some color that we've never seen. It takes a lot of, like really thinking hard about what that might look like, but it's just so exciting and rewarding at the same time.
I'm excited just kind of hearing you talk about it as someone in a different field. And I feel like something so fascinating about planetary science is throughout history, you talk about in your book, how it's really inspired public imagination and the imagination of people who have never thought about science or never even learned science before. They're all fascinated by this idea of life on another planet. That kind of brings me to my next question about one of the most popular astronomers, was Carl Sagan. And I was struck by in your book, you talk about in chapter 4, Carl Sagan had what some people thought of as a lucrative optimism about the Viking mission and life on Mars. He would joke with reporters and encourage the public to use their imagination of what life on Mars could look like. But after the Viking mission showed that life on Mars was improbable, a lot of his colleagues actually criticized him and saw him as a showman who was, quote, setting the public up for disappointment. So I'm curious your thoughts on, do you believe there's some value in doing what Carl Sagan did and what some scientists do today in inspiring public imagination, even if those experimental results then don't live up to those imaginations?
Oh, absolutely. Carl Sagan, he was a really fantastic scientist. He was an extraordinary communicator, but he also was very much willing to call a spade and integrate data with his outlook. And he did have this sort of optimism that was running through so much of his work. But I think that there's also this other problem where you have this failure of imagination where you just can't see these possibilities. And Carl Sagan, I think one of the most wonderful things about him was that he could just always see possibility in ways that some people wouldn't even be thinking about. I still think about those images of those craters that came back from the Mariner 4 mission. Everybody was just totally just knocked on their backs thinking this is it. But Carl Sagan was like, wait, and he went off and he found a bunch of images that had been taken at that same resolution, about 1,000 meters per pixel, it was kind of the dawn of weather satellites. So there was the TIRRS-1 satellite and the Nimbus satellite. And he amassed all these images and he looked at them and he was like, hey, you can't even see cities. There's nothing here that says that this is a lifeless planet. And then he even went an order of magnitude to higher resolution, about 100 meters per pixel, these images that have been collected by the Gemini astronauts and the Apollo astronauts. And he got so many of them, hundreds, about 1,800 of them. And he looked at them and he said, okay, so in some of these, you can actually see a trace of life. You have to know what it is you're looking for to really understand it. And he was just, it was, part of his way of saying, we're not done with Mars, let's keep going, let's go back. And I just think that's so valuable. And that kind of creativity is just so important to the field. And Carl Sagan, I mean, he was always kind of a hero of mine. And I feel like he inspired so many of my colleagues to go into this field and make it their life's work.
And speaking of some of those like different theories about what the things could be on Mars, I was also really struck by the story of Percival Lowell's career. Lowell being a really early astronomer who was so convinced that the lines that they thought to see on Mars were evidence of man-made canals and an advanced human society. And his theory seems really wild to us today, but at the time, it seemed somewhat plausible that these canals could be made by a similar advanced life form. And he held on to this theory until his death, even though it started to be disproven sort of later in his career. And I was really struck by his stubbornness as a scientist, because even in the face of all this evidence to the contrary, he continued to argue that these were sort of man-made canals. And I'm curious, as a scientist in this field, do you think that this sort of determination that Lowell showed to defend his theory was all sort of foolish, or do you think it's somewhat necessary for scientists to kind of stick by their guns and hold on to theories when there's a little bit of dispute?
Yeah, oh gosh, so Lowell was such an interesting character, and he was certainly a product of his time. Like you think back, it was just such a wild time in this country. We had all these new technologies, like even radio, the idea that you could communicate across large distances using these invisible waves. I mean, that was crazy. And like, this is the time that like even Tesla and Marconi, the sort of rival inventors of radio, were even thinking about maybe communicating with Mars. Tesla at one point, I think, said, Mars is only 5 minutes away by wireless, just imagining that if there were these advanced civilizations, like maybe we could just talk the way that suddenly the United States was able to talk to Europe. And it was just so bizarre. So Lowell wasn't like alone in sort of this idea. And it was this time too, where these giant public works were like suddenly these human creations, like the Panama Canal, like things were suddenly being visible from space, these giant earthworks. And so, I mean, if we could make canals here, why not? Why not in this heyday of canal building, where everybody's building canals, why not up on Mars too? And he had all these theories, these like wild theories, just about how like there were this benevolent oligarchy that has taken over Mars and it's irrigating, bringing water down from the melting poles to the equatorial regions. And I mean, the thing about Lowell, though, is you're right, he was incredibly sort of stubborn. And, like I think that having passionate advocates on different sides of scientific debates is hugely important. But he, unlike Sagan, didn't seem to show that same willingness to kind of incorporate data into his worldview. I mean, he also had a very different kind of training, like Sagan, of course, went through academia, had a PhD, like did a lot of this. But, back then it was a lot of amateur astronomers. Lowell had been like, just traipsing through the Far East as a diplomat. He'd studied all kinds of things as an undergraduate, but there wasn't like sort of a formalized set of scientific training. And maybe that's partly why, because he was, doing all these different things, but it just didn't seem to do that crucial thing where you sort of take in new pieces of evidence. And, and that's something that, really no credible scientist can endure, especially these days. And so I guess it was a weakness, in that sense. But I mean, at the same time, like that was what was so great about somebody like Sagan, because even a failure, like he could take a failure and he could explain that to the public in a way that we all learn from it and sort of help us understand that even failure sort of marches us toward this truer understanding of what this place is and what reality is, and like uncovering truth. And that's so valuable, and that's so part of the scientific process.
Yeah, I think that's a really helpful kind of comparison between these two scientists you talk about. And I really enjoyed how the book was written in a way where you kind of were meeting these new characters throughout history, like really big people in their time, like Sagan and Lowell. And another really interesting character we encountered was William Pickering, who was this astronomer who preferred to collect data in really remote areas and report on them directly to the public via this popular astronomy magazine. And he often criticized sort of academics on the East Coast who published in scientific journals. So in this way, Pickering was somewhat of a radical popular scientist, and he helped make astronomy more accessible to the public outside of academia. So I'm curious, as a scientist yourself, what do you see as the role of citizen science today? And do you think it holds a value that, as Pickering believed, some academic science sometimes misses?
Yeah, Pickering, he will always have a place in my heart. He moved down to Jamaica on the cusp of World War I and was just sending these beautiful missives back to North America, just what he saw in the night sky. It was almost like this refuge from all the sort of human violence that was erupting all around the world at that point. But it was, so citizen science, so that question, I mean, I think it has huge value. I mean, I still remember when I was at Oxford with my like clunky desktop computer, and there was this thing that the SETI Institute, the Search for Extraterrestrial Intelligence, had just come out with. It was like a sort of screensaver type thing, but people could sign up for it. And when you were not using the computing power of your, sad little tiny computing machine, you would, it would use it to analyze signals that were coming from space, and it was or looking for different signals, and it was this way of getting people really excited about the SETI, and a lot of people I knew that weren't even associated with space or interested in it would download this and start thinking about it, and I just think it was great for engagement. And so we're still doing things like that with Mars. I know there's this fun cloud spotting thing that a lot of citizen science folks have gotten involved with. Mars, as we were talking about before, we have done a lot of work there, and we've got, we're doing pretty sophisticated science on Mars these days. And so a lot of citizen science, I don't know, in some ways it would be almost under-resourced, and some of the crowdsourced stuff, especially with the advent of new AI platforms, a lot of that is becoming a bit redundant. But I think anytime there's a possibility for sort of citizen science and citizen engagement, I think that's just huge. And I feel just generally with science, we're kind of shockingly underengaged, here in the US and around the world. And I think that's really evident. So you look at the gender gap we see, you look at the underrepresentation of minorities in this field, and anything that we can do to sort of help increase engagement, especially early on, even children, middle school, high school, I think is really, really important.
Yeah, that's I think it leads really well into another question I was going to ask, which kind of someone who is, I think the way that you told it in the book was introducing this amazing scientist who's named Maria Zuber, and she kind of worked on the Mars Global Surveyor team, and then at the end of the chapter you kind of reveal that she then became your graduate advisor, which is so exciting and was really exciting for me to read. And I was inspired by her story because there was a moment when she was asked how it felt to be the only woman on a team of 87 investigators of the 1996 Mars Global Surveyor science team. And she replied that by being so engrossed in the project, she must have stopped noticing that she was the only woman. And as a woman in science myself, I found that really fascinating, because I do think that there are moments where it's, very much so just kind of about the work and about the research. And then there are also moments where it just becomes very glaringly obvious that you're one of, or if not the only kind of woman in a room or in your field. And so I was hoping you could share a little bit about your experience being a woman in such a male-dominated field, and your experience also working with Maria. I'm sure she was such kind of an inspiring role model in that way too.
She's tremendously inspiring. I still just feel so lucky that I had the chance to study from her. And I think also, she was the first woman to lead a planetary mission for NASA, and still now there are a couple more that are in the works, but it's and that was happening right when I was in graduate school. It was a mission called Grail to the moon, and it was just it was so inspirational, inspiring to see, and just I don't know, just being around her, I was just in awe of her in so many ways. But it's interesting, this kind of blindness to to gender, I do think about what it was like for that generation of scientists, and I kind of wonder if there was a bit of a kind of filter function, this sort of this, I don't know. I'm just one of these people that I do feel like I kind of do pick up on these kind of subtle things, or I notice things, like even when I'm super, super engaged in a project, there's still a bunch of kind of social dynamics that I notice, and especially in things like working on missions. I mean, those are such intense experiences, and you're just spending so much time with people, and I do kind of worry that there were probably lots of people that like ended up being sort of filtered out. Other women in Maria's generation that, like just maybe being blind to those sorts of things was what you kind of like had to have to really, I don't know, just to really, be able to focus very, very exclusively on things and keep moving forward. But I just think that, things are so much better now. And because of people like Maria, because of like the mentoring that she's done, because of just being like an extraordinary role model. And I just think now when I go to conferences, even the difference between now and 10 years ago or 20 years ago, it's just there's so many more folks from different walks of life, which is really exciting. And the mission teams now, it's over 15% women participating. And I look at places like, so I spend a lot of time out at Goddard Space Flight Center, which is actually this extraordinary place where Maria also kind of started her career. And I love it. Like there are all these incredible women, and they're like building lasers and like designing missions and like just doing all this incredibly amazing science. And so many of my colleagues are women. And like you look at my lab, like there are more women than men in my lab at this point. And it's just it's wonderful to see things sort of opening up more. And I just hope they continue to in the future.
Mm. And I'm sure that you had conversations with Maria about this as well, but I was struck in your book when she kind of was working on a lot of her missions. There was this element where she faced a lot of overlap between science and also politics, because Maria had to lobby Congress for funding to relaunch the Mars Observer, and also relied then on inviting Congress people to sort of indulge their imaginations when she was talking to non-scientists. And you mentioned, so you did your PPE degree at Oxford, so you have some experience sort of learning both science and also politics. And I'm curious if you can talk a little bit about what's it like being a scientist who works alongside a lot of politicians and other non-scientists, and sort of how do you communicate the importance of some projects to either advocate for funding or to increase public awareness, and when some of the projects are, quite complicated and technical.
Oh, yeah. No, I mean, that was one of the biggest gifts of my time at Oxford. So I had, come in, I'd been doing sort of math and science as an undergraduate, and I got the chance to do PPE, the politics, philosophy, and economics. And, every big scientific endeavor is inherently political. It's got these economic dimensions, and to like actually push big science forward, like it's so helpful to kind of have an understanding of those dimensions. And like we are still, for better or for worse right now, like paying for all of this with like federal dollars and the public's funds, and we have to be able to explain what we're doing. Like, why should they be paying for these things if they're not beneficial? And I just think, again, we've had this gap in our ability to really help people understand like what benefits, exploration can bring, and fundamental science, and like even space exploration. It's not just like Tang and nonstick pans, we get things like the global positioning system. We get like all of these incredible developments in material science and health, and I mean all kinds of things, even in just understanding our own like climate system. How did this planet like Mars take such a different path, and Venus, again, kind of starting off with similar volatiles, goes to runaway climate change. Like it's just so interesting doing all of this, and I think we have to be better about explaining those sorts of things. And I guess that's in part why I ended up writing this book, and why I like doing talks like this and talking to folks and teaching and talking to students and things, because I just think it's really important to kind of help foster that sort of like public understanding of science, and then like kind of getting in there and like helping especially the policymakers and the stakeholders like really understand why it's so important.
And I'm sure sort of as an educator too, as you mentioned, when you're talking to students, you have to sort of help inspire them and hopefully inspire them to love science too and enjoy science. And you talk about one of my favorite moments in the book is you describe sort of the moment you knew you wanted to become a planetary scientist, and how you discovered when you're on a class trip to Hawaii, this fern that was growing underneath a piece of volcanic rock. And you say this really powerful line where you say it was like finding something small, fragile, and worth cultivating deep inside yourself. And I was so moved by that, because I think as a scientist, we also have like, everyone can think of one or two moments when they were really excited and inspired. So I'm curious, as a professor, how you're able to sort of work with students and help them find the same feeling of curiosity. And do you think moments like this are teachable? And if so, how can people sort of do a better job of inspiring others, either in a formal teaching capacity or more informally?
Oh, so yes, can you teach curiosity? That's a deep question. I mean, I guess when I'm working with my students, and I love working with students, I get to work with a lot of undergraduates at Georgetown, and I think it's important to try to find lots of different environments for them to learn in, for them to potentially be inspired in. I try to take students with me to the field every time I'm going out to do field work in some far corner of the world. I like taking students along. That was something that was very inspirational to me when I was younger. But yeah, like, it's so interesting, because I honestly, Sam, I feel like most of the students that I am working with or that I meet in the classroom, like they're already so curious. They're just very curious people. But it's interesting, like kind of as a mother, like I think about that with my kids, because maybe that sort of spark of, oh, let me investigate this, like maybe that comes a bit earlier in life. Yeah, but I mean, I the thing that's coming to mind right now for some reason is like when my son was 6, this was before the pandemic, right before the pandemic, we had like childcare lined up. I had this big field expedition planned out in Iceland, and I was taking a bunch of my students. I was meeting up with some colleagues. Another colleague from Hopkins was meeting us, another colleague from England. We were doing this big kind of field campaign at this like beautiful place where it's like all these glaciers are coming together with these volcanoes, ice and fire. These are these two big forces that shaped a lot of early Mars as well. We were doing some really interesting work there. But we had this babysitter because my son had just turned 6 and he couldn't go to his preschool anymore, but he was about to start kindergarten, but kindergarten hadn't quite started yet. And so we had this gap of a couple of weeks, and it was a mess because my parents were busy and my husband was super busy, and we just had nobody to take care of him. And I just thought, okay, well, I'll just take him with me. And so bought him a plane ticket, and we put his little booster seat in the back of this Toyota Hilux, and we drove him up into the Highlands, and he spent all this time doing research with my students. And it was honestly, like, it just felt like it was such a disaster. And I was like, oh, how am I going to get anything done? It ended up being like some of the most memorable, happy moments of my life, to see him just kind of come alive in that environment. And he was out there, he had so much stamina, and he was so excited to be there. And I think just everything was so different. He had never seen a landscape like this. And he had stayed with us the entire time, these long days in the field, and he would take pictures, and he would run back and tell people different messages and help us dig out samples. And we were doing some field sequencing, and he would sort of monitoring the progress on the computers. And it was so exciting, but just to kind of see the world kind of coming up through his eyes. And it just occurred to me, why haven't I been doing this before? Why am I not just bringing him along or bringing my daughter along on all these things? It's just so much fun for them. And I think that is one of these moments where he was just so intensely curious about this world around him. And I don't know. But then the pandemic hit and we didn't do anything forever. But maybe now that I'm starting to do more field work, I'll get to have some more moments like that. And not just with my kids, but with other kids too.
Oh, that's the cutest story ever. And I have to do a little plug. I'm sure you've taken him before, but I'm sure your kids would love like the Air and Space Museum and the Smithsonian. And I worked there as
Yeah, and Sam, you were working there, right?
I was. So I was in high school. I'm from Washington, D.C., and I worked as an explainer in the museum. And it was just so fun because we get to do all the interactive exhibits with kids and adults too. And it's everyone, I think when you kind of get to do something interactive, you enjoy it so much. So it sounds like your son had that experience at a very young age. And yeah, I think public education opportunities like that are just so invaluable. And so kind of in the vein of these really philosophical questions about like inspiring curiosity, there's this underlying question kind of going throughout your book about, why are we as humans so fascinated with trying to find life on Mars? And you kind of dig into this question a little bit and in some chapters. And one powerful line you wrote says, maybe we would discover that we didn't need to find Martians, that we were Martians. And then a little bit later in the book, we talk about the backdrop of the 2004 Olympic Games. And you kind of question, like, would any of this matter, against the backdrop of an empty cosmos, which kind of approaches it from a different perspective. And it's really this big question of, would finding life on Mars make our life more or less valuable here on Earth? So that's a really, really big question, but I'm curious, kind of having written this book and thinking about these questions a lot, do you personally think our obsession with finding life on Mars is sorts of reveals something about our more introspective goal of finding our place and our purpose here on Earth?
Oh, yeah, for sure. I mean, I think that, like so much of it, it's this duality. Like we have to understand, like to understand the self, you have to understand the other, to like understand who we are. We have to understand the universe and how we came about and like where we came from and why we're here and why is there something and not nothing, and did the something from nothing, did it happen once, did it happen time and again? Like I just feel like those are the deepest, biggest questions that we can possibly ask. And I don't know, I feel like there's this, like we just don't know, right? Like, I mean, there are a gazillion destinations out there. There are all these like planets around other stars, there's so many times, like, this kind of make a planet, see what happens experiment has been repeated, but we still don't know. We've got one data point for life, just this one data point. And it's almost like it's possible that it's just, there was this kind of abiotic before, this flash in the pan, and then this abiotic after, because like at some point our star will explode, the Earth will be gone. Like, long before that, our species will die out. And it's just like, but if there was another point of life, I guess I talk about this a lot in the book, just like what it would sort of mean to me. And I think in some ways it's kind of this manifestation of like immortality, or just like the sense of the infinite, that like even if we're ephemeral, even if our existence is going to vanish, that there could be this possibility for something greater beyond us, like life that would go on. And I think I would find that just so satisfying to sort of find that in my lifetime. And I think I am a sort of restless kind of person. And so, looking around the neighborhood, where it's not just kind of like a distant aberration of light, but where we could actually really pin down an answer to that question is really enthralling to me. And anyway, I feel like we're closer than ever to sort of making that kind of discovery. And it's the kind of thing that really, I don't know, it keeps me up at night, gets me going in the morning, keeps me really focused and excited about what I'm doing.
And it's so inspiring to hear you talk about it. Sort of makes me feel like I should change my field, become a planetary scientist.
Oh, come on over, Sam. The water's fine. We love it over here in planetary science.
And it's so interesting too to kind of see the progression of the field, because there's been this kind of goal throughout history of finding this other this perhaps other planet that has life on it, and yet there's also been so much progress that we've made. And you mention in chapter 2 that after Mariner 6 and Mariner 7 kind of dispelled these theories of canals existing, and we saw the presence of all these craters, you say that both of these showed that the collapse of an abiding belief is always just one flight, one finding, one image away. So sort of the idea of this one data point could completely revolutionize what we think sort of about life on Mars. And I'm curious, now that today we have so much more precise data and so much more of it than we did in the 1960s, do you still think that this holds just as true? Do you think that if we like sort of one finding we make today could disrupt all of our currently held beliefs? Or do you think we've gotten to a place of a little bit more stability in our theories and are a little bit more sure about what we believe today?
Oh, so yes, 100% yes. Like, I think that is still the case. I think that in big ways, I think that in small ways too. Okay, so one example is, so a lot of us, they're like, we could find potentially signatures of ancient life on Mars, like now extinct life, or we might find extant life, still living life. And most of us sort of in the astrobiology community are really focused on the idea of subsurface life, on the theory that the surface of Mars is kind of a sterilization chamber at this point. Mars, early in its history, when it was warm and wet, like at least periodically, like there was a protective magnetic field that was there before the sort of core dynamo disappeared. And this protective magnetic field deflected the solar wind. It also created a lot of protection from galactic cosmic rays, these GCRs. And now there's none of that left on Mars. Of course, we have that here on Earth. We benefit tremendously from that. But without that, I mean, there was no life on land before we had an ozone layer, before we had protection from UV, and UV is not nearly as bad as these cosmic rays, as I'm sure you know as a physicist. And so like, this is one of these things that we are, say, really focused on thinking about, well, what could drilling missions do? Like, what could we find underneath the subsurface? Because even a meter or two of rock is really protective. If you've got like basalt or regolith, something there that is really going to capture and attenuate some of that cosmic radiation, that's really helpful. So I think a lot about that. So if I were a little microbe on Mars, that's where I want to hang out in the subsurface, like this vast amount of life here on our own planet, of the biomass here on Earth is microbial, and it's in the subsurface. And that's a place that we have not even really scratched the surface of on Mars. But, part of that is undergirded by this idea that life on Mars, wouldn't be able to potentially withstand that radiation environment. But like, there's always this possibility that, that radiation is incredibly energetic, and maybe life on Mars, just the way life here developed surface life, because early microbes could harness the power of the sun, those light waves that were coming in to like actually create energy. Maybe there could be, after billions of years of evolution, like a way that microbes could harvest energy from that radiation. It's a different part of the electromagnetic spectrum, but maybe, like, do I think that's likely? Not necessarily, but like, that's an example of something kind of small that could like really upend sort of what we think about in terms of targeting places. But of course, in like big ways too, and of course the biggest is this idea of a second genesis, like a type of life that was totally different from the life that we have here. And I can't imagine anything more profoundly, prompting a reassessment of our understanding of ourselves, our place in the universe, as finding that. And and that's still a possibility also. So again, I just think that, every time we send a mission, every time like we go and find out new things about Mars, like, we do have this like amazing amount of data, and we are amassing and we're moving forward. But if anything, the story of Mars is a story of all these blind alleys and twists and turns and all these things that we have time and again sort of thought, and it was like, whoa, we've been bowled over by how indescribably foreign this place is. Like we see it, like we see ourselves. It's place, you could scratch your knee, this is a place where we know this place, like this looks like the desert, or this looks like Arizona or whatever, but it's not at all. And just time and again, we've seen that. And especially now, I think, and as we start thinking about biology and possibilities for biology, this is more true than ever.
It's so great. And I guess I should now invite, if anyone would like to post any questions in the chat, feel free to, and I'll ask, I guess, one last question, and then we'll open it up also to people, for people to unmute and ask their own questions. But the final question I want to end on is kind of a fun one. And I thought the funniest story reading in your book was about the kind of childlike excitement that the researchers at JPL would have whenever they had a large discovery or a successful landing. Specifically the story about the pranks that they would play on each other, the mini TES team after the Meridiani breakthrough. So they would wrap each other's chairs like in saran wrap and pop letters off of keyboards. And while they're doing extremely serious work, it also seems like a really sort of fun field to work in when you make such a big discovery or seem to have such a big breakthrough. So I was just curious if you could talk a little bit about sort of this unique excitement that's shared by planetary scientists because of the monumental implications of your work.
Oh, I see, Sam. This is why you need to come become a planetary scientist with us, because we do have so much fun. Yeah, well, I mean, part of this is, you know, a lot of times like we get to work on missions, these really intense experiences, but like you've got to like work together. There's like so much teamwork. There's so much kind of sleeplessness and silliness that comes out. We do a lot of work in the field, you know, go off to these places far away and, you know, and just spend a lot of time getting to know each other really well. I do think that there's like some kind of special sauce that like comes into like this kind of group of researchers. And I guess we talk about it in the book, you know, these people, these really different backgrounds, you know, but are drawn together by this common, like unyielding kind of seeking energy, you know, just this kind of quest to like try to figure out these like really profound questions. And I think it is like kind of like a special kind of person, but like, you know, we have these conferences, our astrobiology science conferences, and they're so much fun. They're just so much fun. They're all these like, you know, they're just like the most intensely creative group of people. There's like an open mic night and people are like incorporating all this art and people are doing creative writing. And it's just like this very intensely creative group of people. And I think there are a lot of people, again, you asked about interdisciplinary stuff earlier. I think that, you know, there's certain types of science, and all science I think is good, you know, but there's certain types of science that are like just very, very focused. You know, you spend 6 years learning about a particular transposon, you spend another 6 years doing a postdoc on that same transposon, like that is your career, you're the world expert in that transposon. But I think there's also a ton of value in this science that's like a little bit more, you know, synthetic and bringing things together, and that's more interdisciplinary. And that is definitely what sort of the search for life calls for. And I think that the folks that are sort of approaching those questions that are, you know, pulling all of these different inputs in and really good at kind of problem solving and puzzles and things like that, I think it's just like a really fun group of people. So anyway, Sam, this is my big pitch. Come to the Astrobiology Science Conference with me and I will turn you into a planetary scientist if I can.
Well, very convincing. I guess now is I sort of the prepared questions I had, and I'll invite people to feel free to write questions in the chat or unmute. And I'll start with, I see Jacob has his hand up. So Jacob, go ahead.
Sweet, Jacob Krish.
So good to see you, Sarah. And I loved this book when I read it. And you know, just as you've already been talking about, there's this really artful description of all these different times where the same theory has been made and then crushed, and then it rises again and gets crushed, and it rises again and gets crushed. And so at some point, I mean, so I should also say I'm a condensed matter physicist myself, Sam.
Oh, and we're gonna duke it out, Sam. Do you want to be a physicist?
Like, you know, in my work, and I think also in yours, you have to ask this question of, if every time we get new evidence, this hypothesis that we've been dealing with is disproven, at what point is it just a regressive theory? Like, at what point does it need to be discarded? And at what point do you need to have the optimism of, oh, well, I mean, someone should look for this. And at what point is it time to abandon? Like, where do you draw that line? You are the embodiment of optimism.
No, not always.
Well, I mean, in this way that you've been talking about it, and astrobiology in general. But how do you put that? What's your role as a scientist in this? This goes back to a question Sam asked about Carl Sagan, really. But
yeah, no, I mean, Jacob, it's a great question. It's totally a great question, and there may be a time, and it may be in the next couple of decades where we just say, we've done that with Mars. I mean, we did that with the moon, right? Like, I mean, people originally thought maybe there's life on the moon, and then we're like, no, there's not, and like, of course, we haven't explored every square inch of the moon, like maybe, but we can say pretty confidently that that's probably not a good target for a lot of our resources. As much as I love Mars and think it would be so interesting, I mean, one of the main reasons we're focusing so much, because that is the closest thing, and we started off with just the same stuff, like we were just very, very similar places billions of years ago, around the time that life was getting started here. And then we took these different paths. But like, we certainly may come to a point where Mars, we kind of do the same thing we did with the moon, where it's like, you know what, like we've explored, we've looked at all the data, but we are just nowhere near that point, I guess, is what I'm sort of trying to say. Like, we've sent a couple of missions, we've looked at a couple of things, but there's so much left to explore. And even like the places that would be most likely for life, we haven't even like peeked under the curtain, and so I feel like we are quite a ways off from that, and maybe that's why I feel some optimism there. But I don't know, like the folks that like look up at Mars and see this old rusted out husk of a planet, I feel like they just aren't seeing it the way that a lot of planetary scientists see it. And I think that, like we will have other targets. I mean, like, will we like cease from this sort of exploration? Will we cease for looking for life? Probably not. But, like if we get to the point where Mars just isn't a good place for us to invest our energy, then we push out, we go to the other places in our solar system, out to the other exoplanets. That's what I think.
Thanks for that question, Jacob. If anyone else has a question, feel free to raise your hand or put it in the chat. If not, or in the meantime, I also was hoping to ask if you could talk a little bit about your time working in the White House with the science advisor to President Obama. That seems so exciting. And you talked a little bit already about how you've had some, education and politics and had a lot of crossover between the two. But yeah, I'd love if you could talk a little bit about your experience being a scientist, doing sort of some science policy work.
Oh, that was very, very fun, in a totally different way than sort of anything else I'd worked on. Like I'd spent so much time like in my training, and I'm sure you're doing this, Sam, a lot. Like, you're writing these papers, and they're very, very like kind of specialized, and you've got this, sort of audience of people that read them. But like I felt like there was part of me that was just so excited to see what it would be like to kind of like work on something with like this kind of bigger sense of agency, maybe. And I got this wonderful opportunity to like go down and work in the White House. It was the first couple of years of the Obama administration, and I got to work in the White House Science Office. And it was just such an exciting time. Like science was back on the stage in this big way. And, there were just all these huge issues, that we were tackling, and like on such a scale, like it just seemed like so many of the things that I just felt like I was this kid and I was getting to work on, but they would just have such a huge impact on the lives of so many people. And it was kind of intoxicating in that way. It was really, really exciting. And I loved it. And I loved the people that I was working with. And even just going to staff meetings, I thought were amazing and so much fun. And everybody was awesome. It was awesome. And and so you might say, well, why didn't you stay? And it was, it was something I thought about, like, is academia like what I should be doing when I'm having such a good time here and doing such stuff that just felt very impactful with people that I really liked. And there is a little bit of this sort of thing where, you kind of feel like you're pushing up these things that are just going to maybe get dismantled in the next administration or whatever that is. And so maybe that a little bit, but really, I think I missed tinkering with things. Like, there was so much kind of triage, these things would come up, and there wasn't the kind of time that the luxury of time that I got when I was doing kind of more science stuff, when I was in the lab, when I could kind of like stay up late at night, and instead of just, like reading a couple of papers, making a quick decision, trying to figure out the best kind of thing to do based on the scientific information at hand within like 3 hours, and like typing it out on my BlackBerry and sending it back. Like, I wanted to think about things deeply. And that's why I ended up coming back to academia. And I think it's been wonderful in that sense, just because I just think it would have driven me a little crazy after a while to like not kind of have that bandwidth to really think deeply about stuff again. But I think this kind of back and forth, like a lot of political science types, a lot of government people, a lot of economists, will do this thing where they're sort of academics, but then they'll pop into the administration for a couple of years and then pop back to the university. And I may do that again at some point in the future. I don't think nearly enough scientists do it. And I think that having kind of active working scientists working on science policy is a really good idea.
And it seems like now that you're at Georgetown, it's only in your backyard. So it's really convenient. Yeah. And it's small. Sarah and I were talking about before this, both being in DC, or at least me being from DC. I think it's just such a great city to live in. So small plug for DC as well. So thank you so much. I want to be kind of respectful of your time and see that it's just about 6 p.m. here. So I don't know if there's anything you want to add, any last comments you wanted to make.
Just thanks so much for having me, and thanks to Bob for setting this up. Sweet Bob. And Sam, thank you. This was like such a fun conversation, and I hope that we get together in a couple of weeks when you're here in DC, because I'd love to hang out and continue talking. But thanks to everybody for coming, especially Sarah and Jacob and other old friends.